we are told that a parametric curve below, crosses itself at 3, -1. So we want to find the slopes of the tangent lines at this coordinate. We are not asked to find the equations of the tangent lines, we're just asked to find the slopes. So basically what I'm saying is you have one point with more than one slope at that point. So this is, right here, the very first problem we did in this lesson. And at the point -1, 0, which had two t-values associated with it, because it looped itself there, we could have a slope of +1 or a slope of -1, depending on what t-value, like which direction you're coming from. So the same situation is going to happen with this one. So we're going to graph this. We're going to press y equals, which really takes us to the parametric equivalent of y equals, which is x sub t equals and y of t equals. And t squared minus t, and t cubed minus 4t minus 4. And we're going to press zoom standard. I'm doing this to prove a point. And there it is. All right, so we do not see 3, -1 where it loops and touches itself. So it does cross itself at 3, -1. We're not seeing it. So let's adjust some things on the window. It's not a matter of zooming in or out with x and y values. It's a matter of adjusting the t values. Maybe we don't go back far enough. I like to go back to -2 pi. Even though this problem does not involve trig at all, they usually use 2 pi as a maximum here, as a default. So we'll go to -2 pi as the minimum, and we'll press graph. There it is. See it? We're going to have a slope. Let's graph this again. This is so beautiful. I want you to catch it. I want you to see what happens. Okay, so you don't have to do what I'm doing. I want to watch the process. I wish it would go slower. There's probably a way to do it, but I'm not going to tinker with that right now. Let me tinker. Hold on. No, there's not. Okay. I'm going to press graph. Watch it. Okay. It came around this way, and so at that point, there is a slope associated with this piece of the curve right here. And it looks to be almost 0, but not quite, so negative something, and then it comes back around, and it's going to be positive something. We're going to have two slopes. One of them is negative, the other one is positive. Slightly negative and significantly positive, okay? So I need to know the t-value there. And actually, I lied. I need to know the t-values. There's more than one t-value there because we have more than one t-value that plotted the same coordinate. All right? So here's what's going to happen. We're going to grab the blue pen, and we're going to say that t squared minus t equals 3. And we're going to solve this for t. Now, if you want to subtract 3 and try to factor it, yeah, good luck with that. Not going to happen. This is going to give us the t-value for this one. And then we're also going to find the t-value here. And they better give us the same thing, and they're going to. So for just a moment, let's just kind of switch modes here. We're going to pretend like these are functions. We're going to go to function mode, press y equals, and we're going to just type that in. So x squared minus x equals 3, and we're going to find, standard window, we're going to find where this intersects that more than one place, and that's going to give me a couple t-values, and then I'm going to confirm it over here, if on a test I had time to do so. So, two values, and so second calc, point of intersection, enter, there's one of them, negative 1.302776, so t equals negative 1.303. We'll do that. However, I want to store that as a specific t-value. Now, I'm about to get another t-value, so I don't want to be like, oh, t equals this. So I'm going to store that as, let's call it a. So just for my notes in my head, I know that this last x value, it's confusing, right? I found a t-value. My calculator thinks it's an x value, and I'm going to store it as a. Things are getting out of hand now. So I'm going to call this a. So this is A equals that. All right, let's find another one. And let's see. Second calc, point of intersection, first curve, second curve. Get closer to the point of intersection for your guess. And there it is, 2.3. And I want to store that, which in my calculator is x. On my paper, it's a t. But for the sake of computation, I'm going to store it as b. X stores as b. Way too many letters. So 2.303, and this will be B. Okay, this is not the official way to write it. Sorry, I'm going to call that A and call that one B. Very quickly, I want to do this one as well and make sure I've just confirmed what's really happening here. So let's do this one. T cubed minus 4t minus 4 equals -1. Zoom standard. And I better get the same two values. Okay, so second in calc, point of intersection, we'll go for this one. It better be 2.303. There it is, same thing. And second calc, go to intersect. Enter. Oh, -1. We got another one. Yes and no. Oh, check it out. Okay, I want to zoom in a little bit here. I want to show you what's going on. In the process of doing a problem like this on a quiz, you would not need to go, or a test, you wouldn't need to go into all this detail, but for the sake of explanation, I really like to. It crosses twice. I don't know how well you can see that. Let me move that cursor out of the way. But it crosses twice. This one was cubic, and so it had the potential to cross 3 times. So we already had one of those intersections over here, which is our B value. We have 2 more. One of them is at -1. -1 never satisfies this equation, so we don't use it. But -1.303 does. First curve, second curve get closer to that actual point. -1.302776, that's it. These are our B values, our A value, our B value, which are the T values that satisfy both of these equations. There's an extra one here. Toss it out. Doesn't meet this one. All right. What was all that for? Well, I'm glad you asked. We are going to take the derivative at those specific points. So let's go ahead and find our derivative, and let's just condense this process a little bit further. Up until this point, we have taking dy dt, dx dt, put them over each other. Let's just jump straight in. So the derivative of this over the derivative of that, which would be 3t squared minus 4 over 2t minus 1. Okay. I want to know the derivative at that value. I want to know the derivative at that value. Fortunately, they're both stored in the calculator. So we're going to find dy dx at t equals -1.303. Now, it is -1.3027776, blah, blah, blah. Calculator, I'm not going to call it that. I'm going to call it A. And if you want to say t equals capital A, you can. We have defined it that way. A little slanted and awkward, but we have defined it that way. So, let's do it. I am going to, we'll type that in. Let's see. We have 3a squared minus 4 over 2a minus 1. That's it. -0.303. We're going to put this in context in just a second. -0.303. All right, this is driving me crazy. I like to put a leading 0. I just like to be neat like that. There we go. That's better. And then dy dx at the other t value, which I called b, 2.303, is, again, about to put this in context. You'll see what this means in a second. Let's pull up the last thing we entered. So second and then enter pulls up that last entry. And I'm going to go and change every A to a B, both of them. I don't like exponents. I like to write things several times. 3.303. Okay, we have answered the question, but again, I want to put this back in context. Let's go back to the parametric equation that they came from. So parametric mode, and we'll go to the graph. Not that. Let's adjust our window again. Let's go to a zoom standard, which only shows one of the curves. Let's go -2 pi again. Now we'll graph it. Okay. Again, coming in, drawing this curve, the slope at that point is almost 0, but slightly negative. See it? Then coming back around, the slope of this curve at that point is significantly positive. Isn't that neat? I think so.